Imagine a substance so thick that it takes decades for a single drop to fall. This isn't just a thought experiment, it's a real phenomenon observed in the pitch drop experiment. The pitch drop experiment, which began in the 1920s, demonstrates the flow of an incredibly viscous material. Over the years, only a few drops have fallen, showcasing the extreme slowness of the process. Now, picture the Earth's crust behaving in a similar way, slowly dripping downwards over millions of years. This isn't just a metaphor, it's a real geological process. This phenomenon, known as lithospheric dripping, is a fascinating example of our planet's dynamic nature. The Earth's crust, though seemingly solid and unchanging, is actually in a state of constant, albeit slow, motion. Recent scientific discoveries have revealed that this dripping process is occurring right beneath our feet, particularly in regions like the Midwest. Here, the lithosphere is slowly sinking, affecting the landscape over geological timescales. While it might sound alarming, this geological process unfolds at an incredibly slow pace, imperceptible to us in our daily lives. The ground beneath us is shifting, but at a rate so slow that it takes thousands or even millions of years to notice significant changes. Understanding this phenomenon requires a journey into the depths of our planet, where tectonic plates collide, separate, and reshape the Earth's surface over eons. These movements are responsible for the formation of mountains, earthquakes, and the drifting of continents. Scientists study these processes through a combination of field observations, laboratory experiments, and computer models. By examining geological samples and simulating conditions deep within the Earth, they can gain insights into the slow but powerful forces shaping our planet. The study of lithospheric dripping and other geological phenomena has evolved significantly over the years. From early geological surveys to modern satellite imagery, our understanding of Earth's interior continues to grow, revealing the intricate and dynamic nature of our planet. As we continue to explore and understand these processes, we gain a deeper appreciation for the complexity and beauty of our planet. The slow drip of the lithosphere is just one of many reminders that Earth is a living, breathing entity, constantly evolving and changing. The Earth's crust is not a single, solid shell. It is broken into numerous pieces called tectonic plates that constantly move and interact. These plates float on the semi-fluid asthenosphere, a layer of the Earth's upper mantle. The interactions between these plates are responsible for earthquakes, volcanic activity, and the formation of mountain ranges. Lithospheric dripping is one such consequence of plate tectonics. It occurs when a denser portion of the lithosphere, the rigid outermost layer of Earth, sinks into the less dense asthenosphere below. This process is analogous to a lava lamp, where blobs of heated wax rise and fall due to density differences. Imagine a tablecloth draped over a table with a heavier section hanging over the edge. Gravity pulls the heavier portion downwards, causing it to slowly stretch and drip. This is a simplified analogy for lithospheric dripping. The denser portion of the lithosphere, often weighed down by ancient tectonic plates, sinks into the asthenosphere, pulling the surrounding crust along with it. This process has been observed in several regions around the world, including the Midwest and the central Anatolian Plateau in Turkey. While the dripping itself occurs at depths of tens to hundreds of kilometers, it can have subtle but significant effects on the Earth's surface over millions of years. Geologists uncovered evidence of lithospheric dripping by analyzing seismic waves. These waves, generated by earthquakes or explosions, travel through the Earth's interior, their paths altered by the materials they encounter. By studying the speed and direction of these waves, scientists can create images of the Earth's internal structure, much like an ultrasound scan. In the case of lithospheric dripping, seismic data revealed unusual patterns beneath the Midwest. The waves showed signs of a dense, sinking mass of rock, consistent with the dripping process. This discovery provided crucial evidence for the ongoing geological activity taking place beneath this seemingly stable region. Section 5. The Ghost of the Farallon Plate. The story of lithospheric dripping in the Midwest is intertwined with the ancient Farallon tectonic plate. Millions of years ago, the Farallon Plate subducted or slid beneath the North American plate. This process left behind remnants of the Farallon Plate attached to the underside of the North American plate. These remnants, denser than the surrounding lithosphere, are believed to be the primary drivers of the ongoing dripping process in the Midwest. Like a slow-motion shipwreck, These remnants are slowly sinking into the mantle, dragging parts of the North American plate downwards with them. Section 6. Earth's Interior, a Dynamic System. The discovery of lithospheric dripping serves as a reminder that our planet is far from static. Beneath our feet, a slow and powerful dance of geological forces constantly reshapes the Earth's surface. While we may not perceive these changes in our lifetime, they are a testament to the immense power and complexity of our planet's internal workings. Understanding these processes is crucial for comprehending the Earth's history, present, and future. By studying the subtle clues hidden beneath our feet, such as those revealed by seismic data, we gain a deeper appreciation for the dynamic forces that have shaped our planet over billions of years. Section 7. The time scale of geological change. Understanding the immense scale of geological time is crucial to comprehending the slow yet powerful forces that shape our planet. It is important to emphasize that lithospheric dripping is an incredibly slow process. This phenomenon, where the Earth's lithosphere slowly deforms and sinks, occurs at a pace that is almost imperceptible to us. The timescale of geological change is vastly different from our own human experience. While human history spans mere thousands of years, geological processes operate on a scale of millions to billions of years. While we measure time in hours, days, and years, geological processes unfold over millions and even billions of years. For instance, the formation of mountain ranges, the drifting of continents, and the erosion of landscapes are all processes that take place over such vast timescales. The dripping process in the Midwest, for example, is estimated to be occurring at a rate of a few millimeters per year. It might seem negligible, but over millions of years it can lead to significant geological transformations. To put this in perspective, our fingernails grow at a faster rate. Imagine the slow, steady growth of fingernails, and then consider that geological processes are even slower. These subtle shifts in the Earth's crust may seem insignificant on a human timescale, but over geological epochs they can have profound effects on the planet's surface. Entire landscapes can be reshaped, new landforms can emerge, and ecosystems can be dramatically altered. Understanding these processes helps us appreciate the dynamic nature of our planet and the forces that shaped it over eons. Section 8. No need to panic, a reassuring perspective. The discovery of lithospheric dripping beneath the Midwest might sound alarming at first glance. This phenomenon involves the slow sinking of the Earth's lithosphere, which is the rigid outer layer of our planet. However, it is essential to keep in mind the incredibly slow pace of this geological process. These changes occur over millions of years, far beyond the span of a human lifetime. There is no immediate threat to the surface, and the landscapes we cherish will remain undisturbed for countless generations. It will be millions of years before any significant effects are felt. The slow nature of these processes means that the changes are almost imperceptible on a human timescale. Instead of viewing this phenomenon with alarm, we should take a moment to marvel at the intricate workings of our planet. The Earth is a masterpiece of natural engineering. We should appreciate the complex layers of soil and rock that tell the story of our planet's history. Each layer represents a chapter in the Earth's long and dynamic narrative. The Earth is a dynamic and ever-evolving system, constantly shaped by forces that operate on timescales far beyond our own. Volcanic activity, river erosion, and shifting sand dunes are all part of this grand process. These forces have sculpted ancient mountain ranges, moved glaciers, and created vast desert landscapes. They remind us of the Earth's power and its ability to transform over eons. Understanding these processes deepens our appreciation for the planet we call home. It allows us to see the beauty in the slow, deliberate changes that shape our world. By comprehending the forces that have shaped our world, we gain a greater respect for the natural wonders around us. This perspective encourages us to cherish and protect the diverse landscapes that make our planet unique.